Webb will show us the universe as we have never seen before, from exoplanets to supermassive black holes to the first stars and galaxies. Our present understanding of the universe is both a victory and a tragedy simultaneously. The success is that we have learned so much about the cosmos we live in from our vantage point around a random star inside a typical galaxy in a vast universe. We have identified the fundamental particles that make up reality and the laws that govern the universe. We have constructed a cosmological model that can explain how the universe came to be the way it is, based on observations dating back over 13 billion years and more than 30 billion light-years in space. We finally know what the universe looks like after countless centuries of speculation. But there is a tragedy in the story too, the tragedy of the unknown. We know that the ordinary matter we observe under current physics principles is insufficient to explain the universe on tiny and big scales. At the very least, dark matter and dark energy are necessary. The rate at which the universe is expanding is still a point of contention. We've never witnessed the birth of stars or galaxies. We've never measured the atmosphere of an exoplanet the size of Earth. We have no idea how supermassive black holes came to be. The list could go on and on. Despite this, the James Webb Space Telescope, NASA's newest flagship observatory, is set to begin science operations in just a few months. Here is what we're all excited to learn. The first of the stars. Individual protons and neutrons were generated in the early seconds of the hot Big Bang, and those protons and neutrons fused in the first few minutes to form the universe's initial heavier elements. We believe we know what the ratios of those elements were before the universe generated even a single star, based on a variety of lines of reasoning. We've discovered black holes that are as enormous as 1 billion solar masses 13.2 billion years ago. How did those early black holes grow to be so big in such a short period? It's not impossible, but it's difficult to explain what we see with our present theories. For example, just 100 million years after the Big Bang, a seed black hole of around 10,000 solar masses would need to form, and it would then need to grow at a maximum rate physically possible for the rest of time simply to get there. What lurks in the farthest reaches of space? We rapidly run into fundamental limits when we use Hubble to travel through cosmic time. One is due to the expanding universe, which causes the wavelength of light emitted to stretch. While the hottest, youngest stars release a lot of ultraviolet light, the expansion of the universe transforms that light from ultraviolet to optical to infrared by the time it reaches our sight. A typical telescope will simply not be able to observe anything beyond a particular range of distance. We know where our knowledge's boundaries are today. The James Webb Space Telescope built by NASA will push those boundaries in various ways. We can anticipate what kind of incremental progress will be made and what current unknowns will be disclosed as a result of obtaining this information.